All right, let's talk about zones. I'm going through JNCIA security curriculum and the exam objectives on my own time. And as I'm learning stuff, I'm putting videos together and sharing with you what I'm learning. Also, like the video and subscribe if this is benefiting you. Share these videos with others that you think could benefit also. An SRX firewall is organized in zones. A zone is what forms the basis of what is allowed or disallowed from one interface to another, okay? So if you look at a couple interfaces on this router, you should imagine them as being configured in different zones. This is what's known as a zone-based firewall. All right, let's say this is zone 1 over here and this is zone 2 over here. A zone is made up of layer 3 interfaces, routed interfaces, that share a common security policy, okay, or common security requirements. Like anything on these interfaces back here on these subnets, okay, 192.168.1, 192.168.2, and these subnets over here, we'll just draw a couple zones, 192.168.3, 192.168.4. So these two subnets would share a common security posture, okay? So they could be grouped in the same zone. And the same could be said for these two interfaces over here in zone 2. These two subnets share common security requirements as well, and they can be put in the same zone. And I meant to say firewall when you look at the interfaces of this firewall, not router. It is routing traffic, but more than that, it's firewalling applications and protocols. Let's take a look at the default state of this VSRX. Show configuration pipe display set shows us what the default configuration is in this VSRX. So you have some services, syslog configurations. Now you get into some security stuff. So look at the security stanza. This is going to be very specific to a Juniper security appliance, an SRX, okay? You have by default a screen configuration and some policy configurations, all right? Then you also have zone configurations. You have trust and untrust. To look at the zones of an SRX in operational mode, type show security zones and hit enter. If you hit the up arrow and add ters to it, you'll get an abbreviated output. So what we see here is there are 3 zones: trust, untrust, and Junos-host. They are all type security. Let's look at the configuration again. And we do see reference to trust, untrust, but we don't see Junos-host zone. That is a default zone that is not shown in the configuration. All right. We'll talk about the Junos-host zone later, but for now, I'm going to remove some of the default configuration. I'm going to delete screen, delete policy, and delete these zones. And we're going to put this firewall back together one step at a time. Excuse me, I guess I already deleted all the zones just by doing that. Show pipe compare, and it shows that the screens are going to be removed. There's your minus signs. Policies for trust to trust and trust to untrust are being removed, and the zones are being removed also. What I'll do is I'll save this portion of the configuration for later use so that we can put this back together later on should we need to. I'm going to commit and quit. Show config, pipe display set. Now we can see a very minimal configuration. Now let's look at the zones. Now we see there's only one zone in here, Junos host security. So we're going to configure our zones one by one and get communications going between two attached routers. Okay, here's what we have. We have the SRX called SRX01 connected to router 1 and router 2. These are two Cisco routers down here that I'm just using for testing. We're going to connect those as follows. GE001 and -0/0/2. They will both be connected to two virtual Cisco routers on F00. Don't worry that this is a fast Ethernet interface. That's what the F means in Cisco, and this is a gigabit interface. When you're dealing with virtual environments, you can get away with stuff like that. But in the real world, you would need to match the speeds. You would have to downgrade the speed on these 2 gigabit ports to be 100 meg to match fast Ethernet. But doesn't matter in a virtual environment. Let's start by planning our IP addresses. We will assign 192.168.1/24 to that link, and 192.168.2/24 to this link. We will put the .1 IP address up here for both of those subnets on the SRX, and we'll put .2 down here on these two routers. Over here you can see router 1 and router 2, and here's the SRX in the middle. Let's start by assigning a host name. Set host, how do you do that? System host name, excuse me. SRX-01, commit and quit. Now our SRX is named SRX01. You can see the prompt changes. It still shows the username that you're logged in as. Now you have an @ sign with the configured host name. All right. Show configuration interface GE-001 pipe display set. There is no configuration there. All right, but let's start by setting interface unit 0 family inet address. This is IPv4 addressing 192.168.1.1/24. And then let's put that other subnet on port 2. Show pipe compare, commit and quit. All right, and let's fire up a ping. Let's get a ping going to this first router so that when, well, this is interesting. Oh, that's our IP address. .2 is what's going to be on router 1. Show run interface F00. There's nothing there. It is shut down, so we need to no shut it. No shut. IP address 192.168.1.2. You can't use slash notation in classic iOS. You need to type out the mask. All right, and look at this. Right when we do that, we would have expected to get show ARP. All right, we are seeing an ARP entry here, but our pings are not succeeding. Let's look in the ARP cache on the SRX. Interface GE00. Excuse me, 0/0/1. Excuse me, you have to use the unit. And we do have a MAC address. Let's check that. Show interface F00 pipe include BIA is burned in address. Let's match that. The hardware address of Fast Ethernet 00 on router 1 is C2 Echo 2 Fox 46 0000. So we are seeing a MAC address. Now, let's look back at this again. Show sec zone terse. The only thing we have is a Junos host zone. We're not going to talk about the Junos host zone for now, but we have communication problems that need to be resolved. let's start a ping from router 1 to the SRX. We'll repeat that 1,000 times. And I want to show you something. Show interface, terse, zone. You can look at all your interfaces on this SRX and the zone that they are configured in. So by default, we can see that every interface on here on this SRX is in the null zone. The null zone is another default zone that exists in an SRX that every interface that doesn't get assigned to a specific zone will end up in the null zone. All right. So let's grep pipe, caret is beginning of line, looking for GEs. So that's a cleaner way to look at it. And if we, but you know what? You can't see the zones associated with that. So this is probably the best way to do it. Just highlight that. Or you can do this, GE001, GE002. So we see more cleanly just those two interfaces we're concerned with are in the null zone. Now I'm going to start by configuring a zone for these two interfaces. Set security zones, security dash zone, and I'm going to call it zone 1. I'm going to put these interfaces in here. And you know what? I'm only going to put one in here for now, just to see if putting port 1 that connects to router 1 will at least get this router to be able to ping the SRX. Show pipe compare, commit and quit. And we are still not getting any ping capability yet. What we do see now is that the SRX can now ping router 1, but router 1 cannot ping the SRX. So this is pretty interesting. And we also see that port 1 is in zone 1 now, just as we've configured it, and port 2 is still null. So let's go over here and configure router 2, show run interface F00, and let's start pinging router 2. But you know what? Let's first put that also in zone 1. Let's find that command where we did that. I think it was, let me look for that. Show pipe pipe display set. And let's just copy it. Okay, now they are both in zone 1. Let's start up a ping to that IP address on router 2, so that when it comes up, we will see that in real time. We need to no shut the interface. And there's the SRX pinging. So we know that that's working now. Show ARP. We see the ARP entry for the SRX. Let's see if we can ping it though. So just like router 1 cannot ping the SRX, neither can router 2. However, the SRX can ping router 1 and router 2, as we can see there. So let's take a further look. Can these two routers ping each other? Router 1 and router 2, they are in the same zone. First of all, they're going to need a default route. So let's give them both a default route pointed at the SRX. IP route. There we go. Save that config. Let's copy and paste that over here. Oh, you know what? That's the wrong IP address. Excuse me. Let's say no to that. That should be 1.1. Excuse me. Okay. Let's save that. Let's give router 2 a default route. It's going to be the same, except the third octet is a 2. Let's save that config. Now, let's get these routers pinging each other. It would be 2.2 on the other subnet. Let's do a repeat of 1,000. And look at that. We can ping between the two routers. Okay. So let's look again at the configuration. And one thing I will show you I did a moment ago was I added this policy. Set security policy from zone 1 to zone 1. So what I'm going to do is I'm going to remove this for a moment. Or actually, I can just deactivate it. While this ping is running, I will deactivate this and watch these pings. There you go. They stop. So router 1 and router 2 cannot ping each other. Because there needs to be a functioning policy to even allow intra-zone communications. I want to emphasize that. In order for two interfaces in the same zone to communicate, let's look back at our diagram, and I'll emphasize that even when there are two interfaces in the same zone, so right now we have, this is zone 1. Both of these interfaces are in zone 1. They cannot ping each other without a functioning policy inside the SRX to allow interfaces within the same zone to communicate. This is known as intra-zone communications. All right, and there is the policy highlighted that allows that. All right, security policy from zone 1 to zone 1, and this is what we allow. Matching any source address, any destination address, any application, and then we permit the traffic. Right now we have deactivated that policy, and you can see that no communications is allowed to flow between these two interfaces. So let's roll that back. That's going to be activating the policy. When we commit that, check it out. Router 1 and router 2 are now able to ping. All right, so this is just the beginnings of our configurations of the SRX. This shows zones. This shows the interfaces are in a default null zone unless they are configured accordingly to be in another zone. And even if they're configured in the same zone, there still needs to be a policy to allow that communications to go back and forth between those two routers. All right. We can trace route 192.168.2.2 numeric, and we see, yes, there is communications from router 1 to router 2. I'll even telnet to it, and we'll see that no password is set, line VTY, password, Cisco. There we go. We're now logged into router 2. Look at that from a telnet. So this is good, but we still know that we cannot ping our default gateway. We cannot ping the SRX. So it's very interesting. You can't ping the SRX from router 1 and 2, but you can ping router 1 and 2 from each other. So traffic, if we look back at our diagram here, traffic is allowed to go through the SRX with the policy, but it's not allowed to go to the SRX. Do you get that? Transit traffic is allowed, but not traffic destined to the SRX, okay? However, if you originate traffic from the SRX, you can ping those two routers. We saw that. We can do that, but we cannot originate traffic from router 1 and router 2 towards the SRX. So I want you to look at the SRX for a moment here. and we're going to look at show security flow sessions. All right, there are no flow sessions at the moment. Let's do a refresh on this in real time. And I'm going to send one ping from router 1, repeat 1. Okay, we sent one packet, we get no session. Now, I'm going to now ping the IP address of router 2, which is going to go through the SRX. And let's watch the session table. One packet. There we go. I'll stop this and we will evaluate. We see in from 192.168.1.2 out to 192.168.2.2. We see that it is ICMP type. We also see a code 0 or 7, and we see packet 1 bytes 100. Interestingly, if you go back to look at Cisco, we see that it sent one packet of 100 bytes, and it is ICMP type. We go look in the Junos SRX session table, and we do see likewise. We see that that came in on gigabit 001, which is the interface going to router 1. That is in, and then the packet went out to 2.2 from 1.2. So router, it's going out towards router 2 from router 1. It's ICMP, but the interface it's going out is GE002. All right. Now, if we look at this session table again, it's not there anymore. Well, look at the timeout. The timeout was 4, and then it was 2. All right. So I'm going to leave that running again, and we're going to look at this in real time. This is only one packet. Let's look at the table. Timeout 4, timeout 2, gone. You see that? See how fast that was? So now we can see that an ICMP packet has a very low timeout. The session is built through the SRX, and then it immediately times out right after that. But what we don't see is a session when we try to ping the SRX itself. All right. So we're going to I'll have to dig in, and I'll have to learn a little bit more about that. I think it has something to do with the Junos-host zone. I'm not real sure, but I'll get back to you on that. But hopefully I'll be able to make a video to show how to enable communications to the router, and not just, to the firewall, and not just through the firewall. All right, so this is the beginnings of a zone configuration and allowing traffic between two interfaces in the same zone. Very interesting that you do in fact need a security policy just to allow intra-zone traffic within a zone to flow. All right, well, that's it, and I'll see you in the next video.